Okay guys, in today's session we have seen about what to sort and what are the different type of sorting technique available. So among the sorting technique we are listed on bubble sort is there, selection sort, insertion sort, merge sort, pick sort, heap sort, radix sort. Different types of sorts are available, but it is sufficient to know minimum 5 types of sorting or 4 types of sorting is sufficient. Clear? You people should have idea about this. And the previous session we have covered about what is bubble sort and what is the logic behind it. So we know that bubble sort is one of the sorting technique where the data has been sorted from your right end. So from your right end, each and every data will be sorted. So for each and every iteration where your n minus ith portion will be getting shorter. This is what we have seen to it. And today we are going to see with selection sort. So first let us understand the logic behind selection sort. Then we can go ahead with the programming part. Now I'll move on to Excel to make you understand how the selection sort works. Can anyone let me know how does the selection sort works if at all you know already? What is the logic behind selection sort, guys? Bubble sort will compare two adjacent values and nearby values will be compared for bubble sort. What about the selection sort? How the comparison is done? How the comparison is done in selection sort? Guys, ping me. Find the minimum value. Okay. Search for the smallest number in the list. Okay. After this, is that the finding of minimum value or just bringing the element to the appropriate position and swap with the first number? Good. Okay, good, good. So finding the minimum value and swapping with the appropriate position is a selection sort. Here if you are saying. So actually what is the sequence behind is, you should not say finding minimum value and sorting at the first position. You are supposed to say that be at the position and bring the value what is to be placed on the position. For example, whatever your logic saying is right guys, but the way to explain the selection sort, I'll explain you people, just listen carefully. Screen is not visible again. Just I share the Excel. Let me share it again. Is this Excel book visible for you people? Okay. Okay, fine. So let me take a array which has a value 20, 12, 10, 15 and 2. Some random values. Okay. We are going to take an array with values. Now we are going to perform selection sort on it. So we know that the index position of it is 0, 1, 2, 3, 4. These are the index position of this particular array, whatever you mentioned it. Clear? So as per the selection sort, we are going to be at the position and bring the appropriate value which has to be placed at this position. So let me paste this one here. So the logic what you said is right, but the way to explain if someone is asking is bring a value to it, bring the concerned value to this position. You're supposed to be at the 0th position initially. So what is the value? If at all you're going to arrange in the order, which is nothing but ascending order. So what is the value to be placed? The overall minimum value will be placed in this position, right? So find the minimum value in this particular list and bring here. Find the overall minimum value. First you take this as your minimum value, then compare with the next one, compare with the next one, compare with the next one, and what happened, you can able to find this is the overall minimum value So you'll be finding this is the minimum value, just perform swap operation with that particular position. So 2 and 20 will be brought to this position. So this swap is done. So at the end of this operation, I can able to conclude that where my first element has been shorter, you should not disturb this element after this. So again, what you're going to do is you're going to move your pointer to the next element. I know that the first element is shorter, so no more you're not supposed to disturb this element. As we see in the bubble chart, the last element will be sorted for the first iteration. Here in case of selection sort, the first element will be sorted. This is nothing but be at this position, find the overall minimum value in this array, then bring the value to the appropriate position, then move your pointer. Now your pointer will be here, and now I will find the next minimum value. If at all you are going to do in ascending order, we are supposed to find next minimum value. If at all you are going to do the same logic for your descending order, you are supposed to find next maximum value. The logic varies depending upon the order what they are giving. Okay. Now, just a minute, guys. Let me check whether on the recording. Yeah, recording is on. Just okay. Fine. And after this, I'm supposed to find the next minimum value in this list. Next minimum value is 10. So this is the next minimum value. So you're supposed to perform swap operation with this value. So what happened? Your 10 will come here and your 12 goes here. Okay. And right now, this data is also sorted. The value at the first two position has been sorted at the end of your second iteration. This is a result of your first iteration, and this is a result of your second iteration. And next is moving ahead with your third iteration. From this array, you're going to perform third iteration operation. So from this particular pointer, where your pointer will be moved to the next position, which is nothing but it will be moved to this particular position. Sorry, guys. So it will be moved to the next position. It will come here. So right now, I'll check the next minimum value. The next minimum value is at the appropriate position. So no changes will be happen. It will be as such. Again, I'll take your fourth iteration. I'll take my value. So your pointer will be moved from this position to the next position. And this data is treated as a sorted data. So for each and every iteration, after first iteration has been done, where your traversal checking will be done only from 1 to 4. After second iteration has done, where the traversal will be done only from 2 to 4. After third iteration, it will be done only 3 and 4. So right now, these two data will be checked. This value is less than 20. So this data will be considered as your sorted data for your fourth iteration. So clear with this? So no more iterations required for the last data, it terminates. So if at all the value is 5, how many iterations is required for me to arrange this data here? N minus 1 iteration is required. Guys, is this clear how the selection chart works? Be at the first pointer, bring the appropriate element to be placed on the particular position. Bring it to the particular position, move your pointer, next search for the particular element. So the searching should happen only at your right end. You're not supposed to bother at your left end. The reason is from the left end you keep on sorting. Is this clear? Guys, everyone respond me. Okay. Will you people write logic for this one? Selection short. It is very simple, right? Okay, try it out. You can take 5 minutes of time. Just try it out. I need the logical part alone. Try it soon. This is the logic behind it. And one more thing, guys, whenever you people are writing program, have a habit of writing the program by using functions. Right now here, if at all you are using mobiles or laptop, whatever it is, you can write the logic directly. But whenever you are going to write some competitive exam or wherever you are going to write a program, just have a habit of writing by using functions, which is one of your coding ethics. Just let me write outer skeleton alone here. I want you people to complete the program. You will try with your logic there. No need of waiting for me. Just I'll write the outer skeleton part on here. Come on, try it soon. It is very simple, guys. Just I told you, you're supposed to traverse the array for each and every time. You're supposed to be at the position. First, be at the 0th index position and go from 0 to n and find the overall minimum value in the list, in your array or list, whatever you're using. Just bring the value to the 0th position. Then move your position to first position. Then find the next minimum value in your list. So this is a process which you're supposed to continue again and again. Come on soon, try it out. After a long time, I could see 46 members are there. Okay, Srikanth. Okay, repeat until size minus 1 time. Why is this, Srikanth? You are writing algorithm. If possible, try to write it as a program itself. Okay. So if at all you're writing program, it will be easy for me to fix out your errors. If at all you're doing some errors, it will be easy for us to fix it out. Writing as an algorithm, errors cannot be fixed out. That's the reason. Okay. Repeat size minus one thing. Good. Good, good. Your logic is right. Good. Guys, very simple logic only. Selection sort is not that much complex. Okay. Good, Potyajin. Good. That's good. The code is right. Others, come on, try it out soon. Complete soon. Guys, I got only 2 response. Others, soon. 5 minutes is over. It's more than 5 minutes. It is not required this much time to do it. Okay, shall we discuss here, others? Are you people trying it, or shall we discuss? Just ping me how it is all about. Okay, we'll discuss. Okay. Guys, at least response to this. If at all you're doing, just let me know. I'll wait for a few more seconds. Or if we'll start discussing in this, and if it is fine, just let me know. If at all you're being quiet, what should I do? Okay, we'll discuss. Okay. Fine. Okay. We'll discuss, yeah. So from here, listen carefully guys, we'll see one of the important method, our declared array directly. And does it know the size of the array here? How to calculate size of the array if the size of the array is not known? Is there any specific formula to calculate size of the array when it doesn't know the size of the array? Is there any formula guys how to calculate size of the array? How will you find the size of one character? For example, let me assume I'm not going to have this one. Let us assume your int value is 5. I want to know what is the size allocated for this particular number n. How can we find it out? How can we find it out? Have you heard about this keyword called size of? Yes or no? Size of keyword. What is the purpose of this keyword? What is the purpose of the size of keyword? Have you came across this size of keyword? Yes. What is the purpose of it? What is the purpose of it, ma'am? If I use size of, for example, if I use size of integer, what will be displayed in your output? So you can notice that let me give two statements. 2. Okay. So what is giving here? So if you give size of int or if I give size of float, let me execute it and show you what happens. So if at all you are using size of, what happen? It will display the number of bytes required for concerned data type. So here we are using 64-bit compiler, so it will display 44 as the answer, which is nothing but 4 byte for your integer and 4 byte for your float. Don't be confused that only in case of 32-bit machine it will occupy 2 byte. Apart from 32-bit compiler, wherever you are running your program, integer will take only 4 bytes of memory space. So that is the reason it's displaying 4 as your output. Clear with it? Now coming back here, so we know that if at all you want to calculate size of one element, I can make use of size of. So if at all I want to calculate the size of the array, how can I calculate? I doesn't know what is the size of the array. I've initialized it, but size is not given. Where an initialization of an array without doing size is possible. This can be done, right? If you want to find the size of the array, how can I do? Can we use size of ARR? Size of ARR, is that possible? So if you use size of ARR, what happens? Let me print and show you your n value. Okay, let me execute this and I'll show you what happens. Just I'm not doing anything guys, just I'm mentioning size of ARR alone. And I'm just trying to pin my n value, we'll see what happens. Let me share you the particular output screen. You can notice that your output is displayed as 24. This is the output displayed. If you give size of ARR, it is displaying output as 24. So what is the relation between 24 and the array what we declare? We know the size of the integer is 4. What is the reason behind displaying as 24? What might be the reason? What might be the reason behind it, guys? Okay, leave it. What is the size of one data here? Size of integer, what is that it came? It counts space. No, Chinmaya, no. Size of one data is 4 bytes. So no, we know the size of one data is 4 bytes. How many data is there? You can notice that 6 datas are there. So 4 into 6. Is that clear? So for occupying one data, it will take 4 bytes. For occupying 6 data, it is going to give you 24 bytes. Since array is a group of data, it gives you that memory space required for all the datas. So how can I calculate this size? I can give size of ARR divided by size of data type of the particular array, integer. You can give like this, or you can give in this way, array of 0. Is it clear? Either you can give size of divided by size of int or by size of 0. So in this way, you can able to calculate if at all you doesn't know the size of the array. This is a normal calculation method which can able to do it. This is not at all the formula, guys, which we people are derived by using size of. Okay. Now, what I am going to do is we are going to implement selection sort. So whenever you people are dealing with the array, we people should two things we should keep in mind. Whenever I'm going to pass the array cannot be passed only as array. The size of the array has to be passed. The reason is whenever you're passing ARR here what does it pass? I didn't pass the entire array. From here, ARR we are passing only the base address of this. Base address is nothing but starting address of this array is passed here. So since you are passing this array address, you are going to receive as a pointer. Where I have given you clear explanation about what is base address and how is array declared and how the values are passed. Clear with it? So since you are going to pass the base address, only the pointer can able to receive it. So you are supposed to receive by using star ARR. So either you can receive in this way, or instead of star ARR you can mention empty index. Either by using pointer or by using empty index, it is possible to receive the value. Okay, now I have passed array and its size. Now we are supposed to implement selection logic in this. For implementing selection logic, what I told you, we are going to iterate from 0 to last position. So let me have my I value is 0 and I am going to iterate I less than n minus 1. The reason behind n minus 1 is if at all I am doing this, just a minute, I'll show you what happens. Why I mentioned n minus 1. Let me open Excel. I'll show you people. So it is not required to check this element, right? Once this element is sorted, you'll be checking this element with this element, the third position with fourth position. So once you are going to sort this third element, automatically the last element, that is the lastmost element, so automatically the highest value would be brought there. So it is not required to go till less than n. It is sufficient for me to stop till n minus 1. Your loop is not required to go to n minus, not to go to less than n, guys. It is sufficient to stop till n minus 1. Normally your n value is 5. So now if less than n is 4, less than n minus 1 is sufficient. Is it clear? I'm speaking about the looping, guys. I'm going to go only to 0 to n minus 1. I'm not going to go to less than n. The reason behind is if at all till this, if you are performing this, finding minimum value and swapping it, it is not required for the last value. By default, last value will be the sorted one. So let me go back and let me open it. So what is the, okay. So what is the termination condition? Yeah, I loop is going to be executed starting from 0 till n minus 1. I'm going to execute it. And for each and every iteration, I'm going to increment it. Okay. Now, let me write the loop. So what we are supposed to do? We are supposed to be at 0th position and I'm supposed to find the minimum value, right? So for that, let me take one variable called int and I'm going to store the minimum element position. So why should I store this minimum element position? In the sense, after doing each and every iteration, if I find the minimum value position, I'm supposed to perform swap operation. So that is the reason I declare one variable called minimum value position. And initially, I'm assuming the first value is the minimum value and that is the position of me. So if at all you want to compare who is the highest score in your class, first the roll number 1 will be considered as highest score. Comparing his score with all the score, I can able to find the highest score. Without any default value initialization, it is not possible for me to initialize it, to compare it. That is the reason I'm initializing the minimum value position as I initially. After comparing, this value might be changing. Now let me go ahead with my loop for My j value assigns I plus 1. Compare 0th position with your first position. And your j will be executed till less than n followed by j plus plus. So we are going to be at the position. So being at the position is tracked by your I loop and keep on moving from position plus 1 till end will be tracked by your j loop. Is that clear? So normally I'll be saying that I'll be at 0th position. I'll traverse from till the end. I'll find the minimum value and place at the 0th position. After this, from the 0th position, your I loop will be moved to the first position. So from the second position, I'll traverse till the end. I'll find the minimum value. Then I'll bring to the second position. So this position is holded by using I loop, and the traverser who is searching from the next position till the end is done by using my j loop. Clear with it? Now let me have the operation inside this. So what are you going to do? I'm going to find if at all my array of min is greater than my array of j. So what is min here initially? Your min here is initially 0. What is j here? Your array of j is 1. It is starting from I plus 1, 1. So 0 and first value will be compared. If at all the first value is greater than your first 0th position value is greater than 0 plus 1 position value, what I'm supposed to do? I'm supposed to consider the particular position as min position. Min position is equals to my jth position. If it is not, where your first element is a smaller element and the next element to the which is at the first position is not smaller than this. So what I can do is I'm supposed to go ahead with the movement operation, which is nothing but I should move my pointer to the next one. Is that clear, guys? And if at all I find it is less, that's fine. If it is not in the sense, I'll move my j pointer to the next position. Then I'll compare this operation will be compared again. So if I find that my minimum value, array of minimum value is greater than. So let me have some values, guys. Instead of speaking roughly, let me have some values. We'll take this value itself. We'll take this value as an example. So for the first iteration, what I'll do is we'll compare. Just a minute. The first iteration, we are going to compare this particular 0th position value with first position value. The 0th position value is 2 and the first position value is 9. So I'm going to compare whether 0th position value is greater than first position. No, that condition is not true. So no changes happens here. After this, what happened? Your j loop will be implemented. Your j loop from this first point will be going to the second point. Again, go to the values again. Now I'll compare 2 with 5. 2 is smaller, no change. Again 2 with 3, 2 is smaller, no change. 4 with 2, 2 is smaller, no change. 7 with 2, 2 is smaller, no change. So till I reaches less than n, I'll traverse it. Till my end, if there is no change, I'll go up and I loop will be incremented. If my I loop increments, automatically my I loop is already here at the 0th position. Now it goes to the first position. Now if your I pointer is at your first position, your j pointer moves to second position, which is nothing but I plus 1. And right now you can notice that where your minimum position is assumed as your first position. Now I'll go ahead here. I'll check at this point. I'll be at this point. I'll be at this point. There is your I pointer and j will start here. I'll check here. 9 is greater than 5. Yes. So if it is greater, what happened? The particular position of the j will be set as minimum position. So already is 1. Right now your j is 2. So 2 will be set as the minimum position value. After this second position, again it will move. J will move to the third. Since this j loop will go till the end, what happened? Your j will move to the next position. That is nothing but third position. So now I'll check whether 3 is. Right now the person here is 5. 3 is less than 5. I'll check it. Yes, 3 is less than 5. Again, your minimum position will be modified to the third position. So right now at this position 3 will be there. And here, modified it, right? So 3 comes here. It's okay. 3 comes here. 9 will be here. And 5 will be here after this position. So right now here your I position 3 will be here and here this value 5 will be swapped. Again, your pointer moves to this particular position where your 4 is compared with 3. 3 is smaller, no change. Again, 7 is compared with 3. 3 is smaller, no change. Guys, you are not going to perform swap operation here. So I'll not perform swap operation. Let it be as such. So I'm not going to perform swap operation. Just I'm going to store the index position of it. Each and every time I'll store the index position of it. So when you're coming out of this one, when I'm coming out of this one, I'm just keeping track of it and I'm storing the minimum position alone. So at the end of this operation, when your I pointer is 1, at the end of this J loop, I can notice that the next minimum value in this range is present at the third position. So after this, I'm supposed to perform swap operation. So here we are supposed to perform swap operation. Here, let me write swap logic inside this. So before performing swap operation, I should have one condition. If at all your minimum position is not equals to I. So what does that mean? If there is no change, if the element is placed at the appropriate position, no need of performing swap operation. It is an unnecessary step, right? We can avoid it. When this step is not equal, I can able to go ahead with my swap logic. So let me write swap logic here. We'll declare one more variable called temp or safe, whatever you're convenient, you can write it. So let me declare safe and let me have safe assign array of I. Array of I is nothing but the position. This first position will be mentioned by array of I, and this array of I will be swapped with array of minimum position. The position has this minimum position is storing the next minimum value position, right? So this array of I is swapped with array of minimum position, and this array of minimum position is swapped with your safe value. So what happened once you are performing this logic only, the swap of this value 3 with 9 is made. So until unless you are going to just check with the element. Okay, so let us assume right now your I pointer comes to the second position. And your I pointer, let us assume here 4 is there and here 5 is there. The I pointer comes to the second position, 0, 1 and 2. Your initial position right now, your minimum value position is second position. So what happened? Your I value is at second position and your J value starts with +1 position. So throughout the traversal, what happened? Your minimum position will never be changed because all the elements which is towards the right side of it is all the elements are greater. So this condition will never be satisfied. So if at all the element is positioned at the exact position, what happened? Your minimum position and I value will be equal. So it is not required to change it. The element is at the appropriate position. So that is the reason I written this condition. If at all your minimum position is not equal to I alone, do swapping operation. If it is equals to I, already the element is at the exact position, so it is not necessary for me to perform swap operation. This is not a mandatory step, guys. If at all you are mentioning it, unnecessary swap will be avoided. Okay, now this is the logic. It has been completed. I guess everyone is clear with it. Do you have any doubt in the logic, guys? This is the logic behind it. Are you all clear? Shall we print and check it? Okay. We'll have a iterator where your I value is 0 and I value less than n followed by I plus plus. And followed by this, let us print it. Printf %d followed by array of I. Okay. Now let us execute this program. Everything is done. Okay, sorry guys, this for loop has to be closed and then only we are supposed to print it. If at all you are printing it inside, it will print multiple times. Okay, now let's execute it. What is that missing? Okay, where this variable name or a function name cannot be given as a to name. So let me give by using underscore. Variable declarations are missing, guys. Let me declare the variable which is required. So since you have started directly, Certain variable declarations are missing. What is that here? Min. Okay, let me close this one. Min position. Small layers. Colon is there. Okay, sorry guys. Small errors. Okay. I'll share you the output window. You can notice that the input, whatever you are given, has been sorted in the order. It is in like ascending order. 2, 3, 4, 5, 7, 9. Okay. Is this clear? Do you have any doubt on it? Shall we proceed to next one, next type of sorting? Okay, good. And next is, we are going to see with insertion sort. What is the logic behind insertion sort? What is insertion sort all about? Come on, respond me. Insertion sort, you might have heard about it, right? What is this all about, insertion sort? How does this work? What is the working logic of insertion sort? I'll give some example. Just try to explain what is it, if at all you know. Guys, come on, don't be quiet. Let me know whatever you know. Forgot. Okay. Others, Srikanth has forgot. What about others, guys? If at all you're being quiet, what does it mean? Okay. Okay. We'll discuss. Insertion sort is nothing but inserting the value during a movement. It is not, you're supposed to, in case of selection sort, what we did, we are at the point and bring in the appropriate element to the point, right? But insertion sort is not like that. Taking the element and inserting at the appropriate position. So normally we'll have two pointer in case of insertion sort. We'll have two pointer. One is I pointer and other is J pointer. Roughly speaking about the insertion sort, it is all about we are supposed to, for example, let us assume I'll be at this position. I'll give you the rough calculation what does it does. Okay, I'll be at this. I'll compare these two elements. Just a minute, guys. Sorry, guys. Okay, we'll take the same array. Just I'm going to give a naive way of solving. Naive in this is rough calculation. Then we can go with the logic wise. First, what we'll do is we are going to take will be at this position. Your starting of the insertion start will start at first position. I'll compare these two elements. So if at all this element is less than this value, I'll perform swap operation where this value will be modified as 3 and this value will be modified as 5, such as 4. Okay. Now I'll take the original array. At a next iteration, where does your pointer goes? Right now this is 3, so this is 4 and this is 3, right? After modification. After this, your pointer reaches at this position. What I'll do is I'll check with this value. Where this value is less than this value. Yes. So then what I'll do is I'll move my element here. Again, I'll move my pointer here and I'll check where this value is less than this. If it is so, I'll move my pointer here and my value will be brought here. And after this, if there is no more iteration, I reach just -1 position point in the sense. Now I'll perform my insert operation. Is it clear? I'll take a value, I'll traverse to the entire list or the entire array, then I'll try to perform insert operation, where I'll shift all the elements. Is that clear? Here, in case of single element, you'll never find the difference, where your one pointer is there and one pointer is at this position. Right now, I'll check where this element is less than this first value. Yes, it is less, so simply swap it. So there is no more element to be compared. After this, only the -1 index position is there, so no more comparison, you'll stop it. Same way, I'll move my pointer here. After moving my pointer to this particular index position, I'll compare with this value. Okay, I'll compare with this value. It is greater than this value, so I'll do shift operation. After this, again I'll take this value. I'll keep this value in some temporary variable or safe variable. I'll keep it safe. Initially, the first step is I'll take this value and keep it safe. The same way here, I'll take this value 2 and I'll keep it safe. Then I'll perform swap operation. Whenever I'm going to perform swap operation, I'm going to implement it. Initially, I'll take this value 3 and keep it in safe. I'll compare this 3 value with before value. If it is there when there is no more element, all the elements towards this left side is smaller than it, then I'll stop it. You can notice here, I'll take 2, I'll perform comparison with 4. When I find that 4 is greater than, so 2 is less than 4, I'll swap this 4 here. And again, my pointer stays at this particular point and one pointer stays at this point. I'll move my pointer here. So I'll compare this 3 with 2 again. So 4 with 2, I'll move my pointer. Again, I'll compare 3 with 2. Again, I'll move my pointer. After this, no more element to be compared. Then I'll perform swap operation. So for the next iteration, guys, once 2 to 3 iteration is going, then you people will be clear, guys. Don't be confused. So right now, after swap operation, this could be your original value. This could be your original value. Right now, your pointer will be at this position. So right now, which value will be at the safe? The element where your pointer, that element will be put in a safe. Okay. Now I'll take 10. I'll compare with this value. No, it is smaller. This value smaller. This value smaller. No changes at all. Then I'll take next value in my safe. There I'll move my pointer. Next value is 12. The next value is 12, where your pointer will be at this position. So this 12 will be compared with 10, compared with 4, compared with 3, compared with 2. This value is greater, so no change. Again, I'll move my pointer to my next value, 1. So listen carefully. Here you can notice the major difference of insertion short compared to all the values. This one has to be moved to the first position. Listen carefully. So right now your pointer moves to 1. Okay. Now this 1 is compared with 12. 12 is greater than 1. So what happened? Automatically 12 should be shifted here. After this, my comparison pointer goes here. From this point, my comparison pointer moves here. It moves here. And now I'll check whether this check is done and this swap is, let me remove this highlighter. It will be confusing if I'm editing. So this value has been moved. After this, I'll move my pointer here. Guys, make sure that we are having 2 pointers. So the 2 pointers will be moved consecutively. That is the reason I'm keep on saying you we are having 2 pointers. One is here and one is here. For each and every iteration, the 2 pointers has been moved consecutively. So what happened? Your pointer moves here and one more pointer moves here. So I'll compare 10 with 12. This particular 1 is lesser, so what happened here? 10 has to be swapped back. Again, I'll come here, I'll check whether 1 with 4. So 4 is greater than 1, so again your 4 moves back. Again, I'll take 3. Now I'll check whether 3 is less than 1. No. Again, your 3 will be moved back. Again, I'll take 2 and I'll check whether 2 is less than 1. No. Your 2 will be moved back. And after this, there is no more element to be, since it is the last element, it reaches -1 position. So this is a point where one should be inserted. Clear with it? This is how your insertion sort works. If required, let me put one more box also. Let me show you for 4 or 5 also. Guys, I'm showing only the logic. I'm showing only the naive approach. I didn't use any logic or iterator. I didn't show you. Just try to trace it by your own. Very simple. By having 2 pointer by your own, you can do it. After this till this iteration is done. After this, where your safe value will be moved to 5. Right? This is your safe value. Right now, your pointer will be at this one. You can notice that your pointer is incrementing one by one from first position, second position, third position, fourth position, fifth position, sixth position. Okay. Right now, it is a sixth position. Right now, your safe value is this, where this value is this. And right now, I'll compare 12 with 5. 12 is greater than 5, so 12 will be moved. After this, where 10 with 5 will be compared, 10 is greater than 5, it will be moved. Okay, after this I'll move my pointer where I'll check whether my 4 is greater than 5. It is not greater, so automatically my value will be inserted at this position. So whenever your safe is less than this particular position, it will be working. Whenever you find that your safe value is greater, no more iteration. So you'll be stopping here itself and you'll be inserting the value at that position. So the value inserted is done at this position. Is this clear, guys? You'll never always go to the -1 position. If the value is minimum, in the sense you'll go till the end. So you can notice that 5 in this position the 5 has to be inserted. So I'll compare 12 with the safe value. Yes, the 12 is greater. I'll move my 12 backward where the 5 is there. Again, I'll take 10. I'll compare 10 with 5. I can able to find that 10 is greater than 5, so it will move. Again, I'll move my pointer here. I'll compare 4 with 5, where only a safe value is greater than the particular point. So no more iteration will happen. So at that point, you're supposed to break it out and you're supposed to insert the safe value in this point. This point is called point of insertion. So for each and every iteration, you're going to find the point of insertion. Then you're supposed to perform insert operation. For each and every iteration, will never insert it. Once you find the point of insertion, you'll be inserting it, or your loop will go till the end till -1. So if you go till -1, then you can able to find that where the first position is the point of insertion. So this process is all about finding the point of insertion, then inserting a value. Hence, it is called insertion sort. Clear with the logic behind it? Will you people try this one? Come on, respond me. Will you people try it? Okay. Try this one. Just have 2 pointers, guys. I and J. You can have 2 pointer called I and J. Where this tracking is done only by using pointers. You should be aware about the pointer execution. Will you people try it or you find it as difficult? It hardly takes only 4 lines, 4 to 5 lines. Your logic is only a 4 to 5 lines. Little bit, okay. Just try it. I'll help you out. Okay. Try it out. If at all your code is lagging, I'll help you out. You can take 5 to 10 minutes of your time. Right now it is 7:30, right? You can take 5 to 10 minutes of your time, not more than that. Come on, try it out. Try it, try it. Complete soon. Paste the straightener on. Keep it ready. Complete soon. Come on, guys, soon. Guys, don't be quiet for a long time. Try it soon. Just hardly it will take 4 to 5 lines. Or else shall we see logic wise? Failed. Why, what happened? It's not working. Okay, shall we show you the logic wise, step by step? Confusing. Okay. I'll do one thing. I'll show you people logic wise. Okay, one by one I'll show you by using logic wise. It'll be easy. Okay, I'll open the X. Guys, I'll show you by logic wise. Wait a minute. I thought if people will trying it, no worry, even though just give it a try is enough. Listen, yeah. So what is this? I'm speaking about this. We are going to have three variables. I told you that we are going to have two pointer where you're going to have one pointer start with first position and one pointer starts at I minus one position. If I always starts only at this position, guys, the reason is I'm doing my swapping or I'm just taking a value at your right side and just inserting at your left side. So I need two pointers. So one pointer starts with first position and next pointer starts with zeroth position. Now I'll have three variable, one variable called safe and one variable called I and other variable called j. For tracking, I'll have these three variables. And initially, your ith value will be at the safest point. Your I will be at this position and your j will be at this position, where these two value has to be compared. So these two value has to be compared. What is the condition I'm supposed to apply? Whether my safe is less than my array of 5. This is the condition. This is the condition are we people using? Whether 3 is less than array of 5. This is the condition I'm supposed to use. Where not array of 5. That's array of j, right? I'm comparing with the jth position value, not the I value. I'm comparing safe with array of j, which is nothing but 3 is compared with 4. Guys, I'm going step by step. Just listen carefully. Just we are going to have a logical flow. So I'll compare whether my safe is less than array of j. So where 3 is less than array of 4. Yes. If it is lesser, what I'll do, I'll keep on move my pointer till the end. Until which I should move, until my j value. My j pointer has to be moved for each and every iteration. I told you we are going to move one pointer, right? That is nothing but for each and every iteration, I'm going to move my j pointer. My safe should be less than your j value, as well as my j value should be greater than or equal to 0. When it is coming beyond this limit, when your j value is coming beyond this limit, what does it mean? Once it reaches minus 1, there is no more element. It is index out of your range, right? There is no more element is there. It is coming out of your index. So I'll apply this condition. When these two condition is true, I'll keep on move my pointer. So at this point, I have traversed, there is no more iteration. When I find that there is a changes in it, I'm supposed to make my normally what happen, I'll check whether j value is array safe value is less than array of j. Yes, it is lesser. And as well as your j value is greater than or equal to 0. Yes, my j value is at 0th position, your condition is true. For the next iteration, what I'll do is I'll again decrement my j pointer. My j pointer comes here. For the next iteration, your j pointer comes here. So now I'll check whether my safe value is less than array of j and your j value is greater than 0. No, your j value is not greater than 0. Then what you're supposed to do is you're supposed to move my j pointer with j plus 1, which is nothing but the 0th position. You're supposed to perform the swap operation. This is how you Guys, is screen visible? Excel is visible, guys? Come on, respond me. I'm speaking with the Excel. Okay, let me share it again. Now is this visible? Okay. Guys, you can notice that just I'm applying condition. Listen carefully. I'll use two pointers, guys, I and j here. So I'm going to compare this. Whenever I value I'm wherever I initialize my first iteration where I value with first position and j value with I minus 1 point. I'll make use of these two pointer and one more variable. These are the required variables for doing this program. So safe, j and I. So I always start with your first position and j always starts with I minus 1 position. So I'll compare my safe value. The element of your I position I'll put in safe and I'll compare my safe value with my jth position value, whether this value safe value is less as well as my j pointer is greater than or equal to 0. I need to check for the j pointer. The reason is the j pointer I'm going to decrement each and every time. So once you reach this j pointer, there is no more element. So that I can able to find out that the first zeroth position is the position where I'm supposed to perform insertion operation. So I'll apply a condition here whether my j pointer is greater than 0. So I'll check with this condition for the first time if this will be true. So when you find this first time it is true, what I'll do is I'll modify this position with value 4. If you want to modify this position with 4, what is the logic I'll write is, I'll write the logic where my array of, who is this position? This position is, I can mention either array of I or array of j plus 1 is equals to your array of j. Is it clear, guys? A very simple statement. Let me repeat again. Listen carefully. Whenever I find that this particular value is safe value is less than array of j and moreover your array of j is greater than or equal to minus 1, if this condition is true, I'll go inside and I'll make this value to bring this to position. So what happened? Where your 4 will be bought here. This step I'm doing, guys, listen carefully. It will be little confusing. I do know it. Just listen carefully. That this value has to be bought here. I didn't bring 3 immediately. First, if I find that this particular position value is greater than your safe value, immediately I bring my value to this ith position. Ith position is nothing but j plus 1 position is the ith position. So j plus 1 position will be initialized with array of jth position. Okay. And next is, after this again what I'll do is I'll keep on decrement my j value. After this you can notice the j value reaches minus 1, which is your termination point, which is nothing but I'll apply a condition whether j value greater than 0. Right now your j value, if you're decrementing again reaches minus 1, no more step is there, it will terminate. So unit is terminating, I should come out of the loop and I should make my array of, so right now your j will be at this position after this comparison. So first initial j is here, your j will be swapped with j plus 1 position. Okay, this position will be modified with array of I and after this I'll decrement my pointer here. So that your pointer will be at this position and right now the value to be inserted will be at this position, that is nothing but where your array of j plus 1 will be modified with the value of safe. Guys, if I repeat the second step, you'll be clear, guys. Don't be confused. It is very simple. Once you're going for second iteration, you'll be clear. So this is process has been made. So at the end of your first iteration, you can notice that the same array will be repeated with this value. So the first two swap will be made. So this is all about the swap of first two elements. After this, if you find, after this, what you're supposed to do, I'm supposed to right now your I pointer and j pointer is here. After this, my loop will go up again. My I pointer will come here and your j pointer goes here. I'll have two pointer, I told you, right? So I'll have I pointer here and j pointer here. And whatever the I value is there, I'll put in safe. I'll compare my, what is the comparison step I have told you? Safe is less than array of 5. What is safe here? 2. Okay. 2 is less than, sorry, not array of 5, array of j. I'll check whether 2 is less than array of j. Yes. And I'll check whether my j value is greater than or equal to 0. My condition is true. Yes, my j value is greater than or equal to 0. The index position is 3. This is your jth index position, right? So jth index position is 1. So it is greater than 0. So if it is greater than 0, what I'll do? Array of j plus 1 will be initialized with j, which is nothing but I'll bring this value here. I'll erase this step, guys. I'll put it this again. Don't worry. So once this 2 value is less than this 4, or when I find that 4 value is greater than this 2, I'll bring this 4 here. That is the step I've written here. Okay. After this, again my condition continues. Again, I'll move my j pointer here, where I'll decrement my j pointer here, where mentioning as j minus minus. Again, I'll check. I'll never do this to swap immediately, guys. Just I brought my value here to this position. This position is mentioned as, if j is here, this position will be mentioned as j plus 1, right? So I'll move my pointer j here. From this position, I'll check whether my safe is less than this j value. Yes, it is lesser. So immediately what I'll do, and moreover my j value is greater than or equal to 0. J value position is 0th position, which is greater than or equal to 0. Your condition is true. So in this case, what I'll do is I'll make my j plus 1 pointer. Previously, j position is there. Right now it is here. So j plus 1 is this position will be modified with the value of j, that is 3. Again, I'll decrement my j value. Right now, your j pointer comes here. So now I'll check whether j value greater than or equal to 0. Your condition fails. If the condition fails, what I'll do? Array of j plus 1 assign safe. Array of j plus 1 is j is at minus 1 position. J plus 1 is this position, 0th position. It will be assigned with the value 2. Is this clear? Your 2 will be modified here. So right now your I is here and your j will be at the 0th position at the end of this operation. So jth position is the point of insertion now. After this I, where does your I value goes? It goes here. And your j value remains here. Okay. Then your safe value will be put here. I'll put here. And now I'll find out where safe is less than array of j. So your safe value 10 less than array of j, yes. And moreover, my j value is greater than 0, yes. So throughout the iteration is going to happen. Your j value will be keep on incremental for each and decremental for each and every iteration. Okay. And once your j value reaches to, no swap is going to happen, where all the values, point of insertion will be, no, all the values are less than 10, so no point of insertion will be found, so the element is at the appropriate position. So after this, you can notice that where your I pointer moves to the next position, a j pointer remains here. And here also your j will be keep on decremented until it reaches minus 1. Okay, it will be keep on decremented until it reaches minus 1. Once you find that there is no point of insertion, again you will come back. So this value should be lesser. If it is not lesser and this j value is not greater than or equal to 0, you're going to break it. Again, the same thing happens. Guys, is this clear, guys? Well, the same first two steps is going to be repeated. Okay, can we move for a program? We'll implement this logic by using program. Okay. What are the variables required? I told you that we require 3 variables. Who are those? One person is to keep the value safely. That person is safe. And apart from this, I need 2 pointer. One is I, another is j. So these are the elements required. And here, I'm going to start from, where is my I has to be started? My I has to be started from the first index position. And it has to go to less than n and followed by I plus plus. These are the iteration. And after this, inside this, I'm going to make immediately once you start the process, what is the first step we make? Where a safe is assigned with array of I. So first, immediately once you start the process, I'll take a value and put in a safe. And after this, my j pointer will start with I minus 1. Always it starts with I minus 1. Now I'm going to start my iteration condition where I'm going to apply while my safe is less than array of j. This is the condition we did, right? So my safe value should be array of j, and moreover my j value should be greater than or equal to 0. This is the condition we are supposed to apply. And after this, inside this, what we did? If this condition is true, I will modify my array of j plus 1 with array of j. And followed by j minus minus. J has to be decremented once it goes inside this one. Else your j value will never be decremented. Only a loop goes again. Clear? Guys, is that clear? Only if this condition is true, your j value will be decremented. If this condition is not true, so we made a small mistake, I guess. Let me go there. Just a minute. We made a small mistake in the logical flow when I'm explaining. So here at this point when we see 10, your j value will never be decremented. The j value remains here only. The reason is this value should be greater than. Whenever it is greater than 1, it is going to go inside while loop and j is going to be decremented. Right? So if it is not greater than, what happens? Your j is not all going to be decremented. It remains as such till the end. Clear? Guys, clear with the logical flow what we made? A small mistake we made here. Should not be decremented for each and every time. Only when the condition is true. Whenever the safe value is greater than that value what you are comparing, array of j, then only it should be decremented. Otherwise, should not be decremented. Okay, we'll come back to the program. Okay, this logic is done. And inside this, what we are going to do is array of, once you are coming out of it, where your array of j should be modified with safe. At the end, after you find the position, till either your loop breaks, if at all your value comes to minus 1. So that might be a point of position, or once you find the point of position, whenever the value is not greater, all the remaining values are smaller, then also this particular point of insertion will be found, and here you're going to perform swap assign operation. The value whatever is kept in safe will be assigned, and after this, just a minute, semicolon is missing. After this, a normal print operation, nothing great here. After this, everything is done. So you're supposed to print your I assign 0, your I less than your n value, and followed by I plus plus. So inside this, you're supposed to print it. Printf percentage %d, comma, array of I. So now let me execute it. Let me share you the output window, guys. You can notice that your data are sorted. Okay, whatever the sorting logic you are using, your data will be sorted. There will be no changes in your output. The only thing is the way how you sort the algorithm. What is the sorting algorithm? The way how you sort is important. Let me share the program again. You can have the glance of it. Just a minute. Look at it and let me know, is that clear? If at all you have any doubt, you can let me know, guys. A very simple logic. I told you the process twice. Normally in naive approach as well as a programmatical approach. Look at it once. Clear. Good. 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 If at all you have any doubt, you can let me know, guys. Before moving on to next topic. With it. Okay, fine. And next is, I thought we are seeing with two algorithm, right? Okay. By tomorrow, we'll be seeing about merge and quick. Now, one more topic is pending. That is nothing but recursion. What is recursion? We'll see about recursion, where other merging algorithm we'll see by tomorrow as a fresh concept, because those merge sort alone takes one separate class. It is a very important concept. Now, if I'm starting merge sort, it is not possible to complete it. It will take about 1 hour to explain about merge sort alone. So for applying merge sort, where this recursion algorithm is very much important for you people to understand. So what is recursion? So without knowledge about recursion, it will be very hard to understand. So first let us complete recursion. What is recursion, guys? I guess you people might have came across recursion. What is that? Come on. A function calling itself. Okay. Good. A function call itself is called recursion. A simple example we can go with it. A normal example which we people always knows, that is nothing but factorial program. I'll take some programs on recursion. Okay, recursion is nothing but a function which calls itself till certain condition. Till certain condition is satisfied is called recursion. What we'll see how this recursion function works and what is the flaw in it. Okay, so let us take a small program, factorial of a number. So let me have a header file, and here we'll have main, and we are going to write program for finding factorial of a number. If it is nothing but if at all the number is given as 5, we are supposed to find factorial of it, which is we'll be writing 5 into 4 into 3 into 2 into 1. The result of this should be displayed as your output. So this particular process can be done by using for loop or by using recursion method. Both the way is possible. So we'll see how to write by using recursion. So let me declare a number and let us accept input from the user scanf %d, comma, ampersand of number. After this, let us call a factorial method and let me pass this number as a parameter. So let me have written 0 at your end. Now let's go ahead with your function definition. So function definition. So let us have void followed by fact of int number. Okay. Now here we are going to apply factorial logic. So what is that factorial? We are going to do here is 5 into 4 into 3 into 1. So when does this loop breaks? Whenever it reaches 1 or whenever it reaches 0, I should break it. So a breaking condition, let me apply if at all my n value reaches 0. Okay. Or if at all my n value reaches 1, I should display or I should return. I should return 1 as my output. Clear. I should return 1 as my output. Let me have this statement inside my printf. It will be easy to display it. So what is the reason for mentioning 1 for number value equals to 1? The reason behind it, even the number 0 factorial gives you output 1. Is that clear? 1 factorial is also 1. 0 factorial is also 1. So if at all the user has given as input as 0, even 0 factorial should be given as a output as 1. That is the reason we are mentioning if at all your n value equals to 0 or if at all your n value equals to 1, I should display the particular number as the output. So this is the logic reason behind writing this one. Okay. And after this, so what you are supposed to do for each and every iteration? I'm supposed to call this function. The same process has to happen again, right? So I'll call this function just by mentioning return what we'll be doing for each and every iteration 5 into 4. That is nothing but a given number into factorial of number minus 1. At the same expression can be written in this way. Would you agree? In this way, 5 into 4 factorial. Would you agree this one, guys? 5 into 4 factorial. The same expression 5 into 4 into 3 can be written as, which is nothing but 5 into 4 factorial. Isn't it? So this is what I'm doing. So 5, the given number into fact of number minus 1. So this process is going to happen again until your number value equals to 1 or if at all the number value equals to 0. Clear? So I'm calling this function again. So let me give you the tracking of use, stack tracking, where whenever you're using stack memory, whenever you're using recursion, it uses your stack memory. The data will be stored only in case of stack. And we have seen how does the stack memory works, the data one after other. Let us assume this fact function is called with the value 5. Just we are assuming that this function is called with the fact value of 5. Just we are going to trace it, guys. Listen carefully. If this value is called with 5, what happens? This condition will be checked. This condition is not true. So automatically what happens? It will give the given number 5 into fact of 5 minus 1, 4. So again this fact function has been called. So this function will call again. So since it is a stack, the data will be called one above other, right? So 4. So what happened? Again this number will be checked. Number is not equal to 0 or 1. So automatically 4 into fact of 3. 3 in the sense the given number minus 1. So this process is going to continue again. Fact of 3, which is going to produce your output 3 into fact of 2. So again this process continues, fact of 2, which is nothing but it will produce you fact 2 into factorial of 2 minus 1, which will give you 1. Okay, again it goes up where the factorial will be called with the value 1. So fact of 1, so 1 into fact of 1 minus 1 is going to give you value 0, right? Is this process will be happening, fact of 1. So at this process what happened? This will never happen, right? So if at all the value is 1, this condition will be satisfied. It will give you only 1. Guys, I have written a sequential flow. So this statement will never be called again. So whenever your fact of 1 is passed, you can notice that this function will be called with the value 1 and this condition will be satisfied. Right now the number whatever you passed is 1. So it will return 1. So as I told you, this is a stack memory. Right now, 1 by 1 element will be popped out. So what is the value here? So first 1 will be popped out and followed by 2 into what is the result given by factorial of 1? That is nothing but 1. So the result will be 2. This result 2 is nothing but result of factorial of 2. Now this value will be substituted. So substituting again, what happened? 3 into factorial of 2 is 2, which will produce the result 6. This 6 is the result of factorial of 3. Again, this 6 will be substituted here. So 4 into 6, which is going to give you value 24. Clear? Again, we'll have 5 into 24. So what is the result? It's going to give you 120 and this 120 will be thrown as a result from your stack memory. So whenever you are using recursion, make sure that your stack memory is used. So the data will be kept as such where the solution of this will be substituted whenever the value is popped out of the memory. So now let me execute and show you what is the result of it. This is of the recursion works, guys. Whatever the recursion program it is. Even if they're asking questions from MCQs, you're supposed to calculate only in this way. Where the rough calculation has to be made only in this way, then only you'll be getting your output. So it is number, right? Given as n. That is the reason it's throwing error. So let me modify it as number. What else mistake we did? So did we mention the return type of the function? I guess we didn't write it. Make it as an integer. Okay. 5 is going to produce, just a minute, I didn't share the output screen. I'll share you the output window. So if at all the value 5 is given, you can notice that the output 120 has been produced. This calculation is done in the method what I have explained you step by step, where the calculation has been put inside a stack, and after this, for each and every iteration, the value is taken out of your stack memory and it has been calculated. Is this clear? How does your recursion works? Come on. It is not like that just the sequential axis 1 into 5 into 4 into 3 into 2. It works in this pattern. Okay. We'll take one more example for recursion, guys. What else we can take? Can we take this linear search? Linear search. Just by yesterday we have seen about linear search. I guess you people could remember. Searching an element in an array. Shall we try this logic by using recursion, linear search? Is that possible? You keep on searching for an element again and again, right? Is it possible by using recursion? Yeah, that's possible. Okay, good. Will you people try it? You can make use of 5 minutes of time. Just try it out. Hardly 3 lines or 4 lines is going to be, guys. That is, we'll never have a huge amount of code. Hardly 4 lines is going to be there. Try it out soon. Even we have seen logic for this linear search also. Where this linear search, binary search, all those things can be mentioned by using recursion. Wherever the looping process is there, this particular recursion is implementable. Come on, try it out soon. Let me write the outer state in here. So if at all you're clear with this one only, it will be easy for you to understand the merge sort, right, guys? In case of merge sort, we'll be using recursion. Merge quick, we'll be using recursion algorithm there. The reason behind it, as I'm keep on saying that whenever you're using stack, it occupies large amount of memory. Even then, why should I use this recursion in the sense? In case of your merge sort or quick sort, where your complexity increases, where the looping process increases. In those cases, if you are writing without this recursion, where your program will be too larger. In order to avoid those things, we can make use of recursion. Apart from this, for a smaller program, it is not encourageable to use recursion. Okay. Come on, try it out soon. Just I'm declaring outer skeleton along, guys. Don't look at this. Just try to complete soon. Not soon. Try it out. Hardly 3 to 4 lines, guys. Not more than that. Were people trying? Everyone is so quiet. Who has completed? Guys, if your people are so quiet, what does it mean? Shall we try here else? Guys, respond me something. Guys, what happened? Can you hear me, guys? Shall we try here yet? I can't receive any response from your end. Okay, yes, posting the answer. Just now I could see the guys. Okay, okay. Good, good. Good, ma, good. Good, Srikanth. Good. Good. That's good. Okay, we'll discuss. Hmm? We're running out of time. If I spend more time in it, it'll be hard for me to complete this one. So let me complete this one. I'll give you few tasks, guys. You can come. I'll give you few sample programs. You can try to it. By tomorrow, we'll be discussing about those problems. Now, in case of linear search, we are going to implement linear search. Here, I'm going to get array, key value and size. Here, what I'll do is, I'll apply the breaking condition first. If at all, my n value is less than 0. N is nothing but my size. If at all, my n value is less than 0 or my array of n equals to key value. Here, how you're going to search is, you're going to search from your right end. You can notice that normally you'll be searching from your left end, right? Here, what I'm going to do is I'll search from my right end. Here, what I kept is, let us assume the elements to be searched is 8. Here, what are the logic I'm writing is, I'm going to start my search from my right end. So from this right end, I'll be going to 0. When it's going less than 0, that is my breaking condition. Or if at all my array value is equals to my k value, just immediately return my position n value as your output. Guys, is this line clear? I'll repeat again. I'm going to start my search from my right end. Till I reach a 0, I'll execute it. Okay, till I reach a 0, I'll execute it. And one more condition, I'll check if at all my array of n is equals to k. When it is lesser, we'll go to the -1 position. So -1 position, I'm applying break condition here. So once it reaches -1, I'm going to terminate it, or my array of n equals to my k value, I'm going to terminate it. And here, for each and every iteration, I'm going to call my linear search again. You can call your linear search again with these values. So let me copy paste here. The code is completed. That's it. You're going to pass your array, and for each and every time, you're going to decrement your n value. Okay, each and every time, you're going to decrement your n value to n minus 1. The reason is, first I'll take 6 and I'll check with all the elements. First is I'll check with my 6. After this, I'll check with my next value, 7. After this, I'll check my key value with this value. So for each and every time, my n value will be decremented and it will be checked with your key value. Is this clear, guys? Is this line clear? I'll write my stack tracing here. It will be easy for you people to understand. Just a minute. We'll have a stack tracing meanwhile. So during your first function call, So I'll do one thing. I'll pass as n minus 1. I'll tell you why it is this. Okay. During your first function call, I'll call this function in this way. So let us assume in this array, there is an array, and this array has a value 4, 5, 2, 3, and 1. And in this, let us assume I want to search a key value. I want to search a key value 4, whether it is present or not. So initially, I'll call this function. How this function is called? By passing all this value and followed by a key values. So let me have a track tracing, and I'm going to put it one by one. I'll call array, and here your sizes, n size will be given as 5. 5 element are there, right? But I'm supposed to pass 4 only. The reason is the array of index values start with 0 till 4 is going to be. So I'll call my function initially here itself as n minus 1 only. So this value will be false. If the element is found, it's going to display element found, or the index value will be returned. If the element is not found, I'll check with this condition. For each and every iteration, I'll check with this condition. If at all my n value is less than 0, no. And if at all my array of n is equals to k, my array of n is array of fourth value is 1, which is equals to my key value. No, it is not equal. 1 and 4 is not equal. In this case, what I'll do, I'll decrement my k value, again call this linear search. So if I'm calling this function again, you can notice that again here n minus 1 happens here. So it will be called with the value 3. So this process will happen again till you reaches the first index. So it will be 2, and here after this we'll reach our first index, right? So once you reach this first index, I'll check here if at all my array of 1, first index is 4, equals to my key value. Yes, it is equals to my key value. Return my index position. Okay, not array of 1, it should be array of 0, right? 4, 2, 3, 4, 3, 2, 1, 0. At your 0th call only, not at the first call, at the 0th call. Your condition will be what you're satisfied. So your n value will be thrown back, which is nothing but this is the index position where the element is found. Is this clear, guys? This is how the stack tracing has to be done for this linear search. So now let us go ahead with the implementation part. Let me close this one. Right now it is not required. So let me go down. So everything is done. So here I'm going to check for return my n value. If the element is not there, if the element is there, the particular index position value will be returned. If the element is not there, minus 1 will be returned, right? So I'm supposed to check a condition here. If my result not equals to minus 1. If the result is not equals to minus 1, what you're supposed to print? Enter element found in index position. You can mention %d comma your result. Result is the index position, right? It will be thrown from here. It will be thrown and it will be received here. So let me write the return type of this function as an integer. Else in the sense, if at all the value is minus 1, what I can consider? I can consider element not found. Guys, is this clear with the logic? If you have any doubt in it, your logic just goes in 3 lines. That's it. No more loop, no more condition. Only one condition and checking and calling the function again. Very simple, right? So it makes your program very optimized. Let me execute it and we'll check to it. So what is missing here? It's showing error. What is that? Key is not a declare, I guess. So we'll declare a variable key here. Okay, let me share the output window. Your output window is shared. Now, the key value, what is the key value we can take to it? Let us take a key value as 4. The element is found at the first index position. This is the output is displayed. Now let us go back and check whether the 4 is present at the first index position. We can notice that 4 is present at the first index position. Is that clear? Do you have any doubt in it? Come on, respond me. Okay, fine, good. Guys, I'll give you 2 or 3 programs. Just try to it, okay? Binary search by using recursion. Try out binary search. In the last session, we have seen binary search, right? Try this binary search by using recursive method. We'll discuss in next class. Okay? Okay. Okay guys, do you have any doubt in today's session? Today we are covered with selection sort, insertion sort, and what is recursion, and 2 programs on recursion. Okay guys, thank you. See you tomorrow. I guess tomorrow is the last session. If at all you have any doubts, you can note it out. You can ask me by tomorrow. Thank you guys. Thank you. Thank you. Good night.